Hello everyone! I'm going to show you an incredible trick, transforming this simple phone charger, often overlooked, into a powerful tool you never imagined. The first step is to carefully open its casing. I'm using a sharp utility knife to gently pry along the seam. You need to be very precise here to avoid damaging the internal components or cutting yourself. We want to get to the circuit board inside. Now that it's open, I'll use a pair of pliers to carefully extract the circuit board from the casing. I'm placing it on this piece of cardboard as a stable, non-conductive surface for my next steps. I'm now applying a small amount of solder to each of the exposed contacts on the circuit board. This prepares them for connecting our wires. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. Next, I'm taking a red electrical wire, stripping a small section of insulation from one end. I'll then carefully solder this stripped end to one of the main input pins on the circuit board, ensuring a tight connection. I'm doing the same with a blue wire, which will serve as our negative connection. I'll solder it to the other main input pin on the circuit board. Remember, good soldering is key for reliable performance. After soldering both wires, I'm using pliers to cut off the excess on the circuit board. This helps to keep things tidy and ensures everything fits back into the casing without causing short circuits or unwanted interference. Now, it's time to carefully place the modified circuit board back into the charger's original housing. I'm guiding the red and blue wires through the opening where the USB port used to be. It's a bit of a tight fit, so patience is a virtue here, making sure not to bend or damage any components. Once the circuit board is seated properly, I'm closing the charger casing, making sure it snaps shut securely. Next, I'm cutting and stripping a longer length of insulation from both ends of both the red and blue wires. We need plenty of exposed copper for the next crucial step. Afterwards, I'll twist the individual strands of copper wire together, making them more robust and easier to work with. I'm twisting half of a red copper wire and half of an exposed blue copper wire together to form a single wire. This consolidates the individual strands into a single strong conductor, which is essential for making good contact and ensuring efficient signal transfer later on. Now for the key component of our DIY antenna, a razor blade. This will serve as the actual antenna element due to its conductive properties and thin design. I'm attaching the stripped ends of our red and blue wires to the razor blade. I'll carefully wrap one wire around each end of the razor blade. This ensures good electrical contact between the wires and the blade, which is critical for our antenna to function correctly. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. After securing the wires to the razor blade, I'm using wire cutters to cut off the excess wire. This isn't just for aesthetics. It also prevents accidental short circuits and ensures that the connections are clean and effective for optimal signal reception. Now, I'm taking a wall socket and beginning to disassemble it. I'm using a screwdriver to remove the screw holding the faceplate in place. With the faceplate removed, you can see the internal connectors of the wall socket. I have a length of black coaxial cable here. I'm carefully stripping back the outer insulation, then the braided shield, and finally the inner dielectric to expose the central copper conductor at one end. This prepares the cable for connection to our socket. I'm now connecting the stripped end of the coaxial cable to the terminals on the wall socket. I will thread the stripped wire through and then use a screwdriver to tighten the screws. This creates a solid electrical and signal connection for our antenna system. With the cable attached, I'm reassembling the wall socket. I'm carefully aligning the faceplate and securing it with the screws. It's important to make sure everything is snug and that no wires are pinched or exposed, ensuring safety and proper function. Now, I'm preparing the other end of the coaxial cable. I'll strip the insulation similarly to the first end, exposing the central conductor and the braided shield. Then, I'm attaching an F connector to this end. This type of connector is commonly used for TV and antenna connections, ensuring a reliable signal path. I'm taking our modified phone charger and connecting it to a power outlet. This seemingly odd connection creates a surprisingly effective homemade antenna. I'm going to show you the TV without our new antenna. As you can see, there's no signal. But watch what happens when I connect our homemade antenna into the TV's antenna input. And just like that, we have crystal clear channels. It's incredible how a simple phone charger and a razor blade can pull in so many signals. This DIY antenna works perfectly. Let me cycle through a few channels. The signal is strong and stable, with no pixelation or interruptions. It's amazing how well this simple homemade antenna works. You can get so many free channels with this ingenious hack. Look at that! Perfectly clear television channels, all thanks to our repurposed phone charger and a razor blade. To really show you the difference, I'll disconnect the antenna. See, no signal immediately returns. But once I reconnect it, bam! Instant channels. It's working exactly as intended. This project truly shows that with a little creativity, you can solve everyday problems with materials you already have. If you enjoyed this amazing transformation and found it inspiring, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me what other unexpected tools you'd like to see me create. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next one.